Okay, so this is our question. This is from Fourier transform. Okay, actually, I think it is not the Fourier transform. It is discrete Fourier transform. Okay, discrete Fourier transform question. Okay, because here we have to find the discrete Fourier transform. Okay, so I think you already know what is the discrete Fourier transform and what is the Fourier transform of discrete time signal. Okay, so normally, okay, you can leave, no issue. Okay, anyone can leave, no issue. Okay, okay, so DTFT is also there. Okay, discrete time Fourier transform. Okay, so you know that when you get the discrete time Fourier transform of a discrete signal. Okay, so if you have a discrete signal and if you get the Fourier transform, discrete Fourier transform of this discrete signal xn, it will be e j omega n. Okay, so this n from minus infinity to plus infinity. Okay, I will quickly explain it. Okay, just a recap. Okay, so this is DTFT, discrete time Fourier transform. Fourier transform of discrete time signal. Okay, so if you have a discrete time sequence xn, okay, so this can be a finite or this can be infinite, no issue. Okay, so you will have Fourier transform x omega. Okay, so you will have like this, n from minus infinity to plus infinity. So this can be infinite or finite. Okay, no issue. So you have xn e to the power minus j omega n. Okay, so this will be your Fourier discrete time Fourier transform. Okay, okay, so you can see that this omega is continuous value. This omega is continuous variable. Continuous variable. Okay, so you already know that if we are dealing with continuous variable in digital electronics, it is hard. Okay, because we have infinite number of values. Okay, I have already explained, I think, this thing. Okay, so you can as example, you can consider a memory, digital memory. Okay, so say there is a digital memory. Okay, so you have some memory location like this. Okay, so this will be your memory location 1, 2, 3. So you have some memory location. Maybe this may be Arduino. Okay, this may be a Raspberry Pi. This may be your computer, anything. Okay, so this each memory location will have some bits. Okay, we don't know. Okay, so now you need to store this kind of signal here. Okay, so if this is continuous, you can see that there are infinite number of values there. Okay, so we don't know which values we should store here because we have finite memory. So you have to install here finite values. Okay, here we have finite memory. Okay, but you have to install, you have to store infinite values. Okay, so that is not possible. So that is why we can't manipulate continuous signal with the electronic device, with the digital electronics. Okay, so if you have discretized this, okay, if you have discrete, if you sample this and if you discretize this, okay, if you sample this, okay, so you will have some sample. Okay, so this will be some infinite sample. So these samples can be stored here easily. Okay, so when we are doing the frequency domain, that is for time domain. Okay, so when we are doing the frequency domain work in the digital electronics, so we like to have discrete time value. Okay, discrete value. Okay, so this omega is a continuous variable. So this frequency component is a continuous variable. So it is very hard to manipulate this frequency domain things with the continuous variable in digital electronics. Okay, so we like to have this we like to have some discrete value. Okay, so what we do is we can sample this x domain signal, or sorry, omega domain signal also. Okay, so we can sample it. Okay. So I sample it like this. Okay, so I get very small sample, and each sample I uh, get like this 2 5 by n. Okay, so this n is finite number, some finite value. Okay, okay, so this n will be finite value. Okay, so if I multiply this by k, and this will be k, and this will be my omega. Okay, so this is the discrete version of the frequency. Okay, so I can write this in terms of k. Okay, so I can write xk is equal to, okay, so please remember that. Okay, so here we are not considering infinite sequence, we are considering finite sequence, and always the number of values here, okay, let's say that is L should be less than or equal to n. Okay, okay, when we are finding the discrete version. Okay, because if you are get infinite values, again there is no useful, no, so you have to get the infinite values there. Okay, so you have to define it. Okay, so you will get this kind of one. Okay, so this n should be 0 to L, some value to L. Okay, 0 to L, and L should be always equal or greater, equal is less than n. Okay, less than n. So we have n, xn e to the power minus j. Instead of omega, I can apply this value 2 5 k by n. Okay. So this is the number of point. Okay, this is the number of sample actually within the 2 5 interval. Okay, n is the number of sample within the 2 5 interval. Okay, so actually this is called endpoint DFT. Okay, this is called endpoint DFT. Okay, so I think you have this basic idea. Okay, I'm not going to explain it anymore. Okay, so xk is equal to n equals 0 to L. Okay, xn e to the power minus j to 5k n, simple. Okay, so this L should be less than or equal to n. Okay, so we call this endpoint DFT. Endpoint DFT. Okay, discrete Fourier transform. Okay, so this is the definition. Okay, so actually no any magic is there. We just discrete this omega. We convert this omega into a discrete variable for a for easiness in manipulating in electronic circuits. Okay, digital electronic circuits. Okay, okay. So we will move to the question. Okay. So we are we are given a signal. Okay, xn. Okay. So you know that xn will look like this. Okay, so un will be to give the region for n values. Okay, this is to indicate the n value, indicate the n value range. You already know that we have done this. Okay, so you have only plus sided value, so you will get like this. Okay, this will be 1, this will be 2, this will be 3, this will be 4. So you will have this kind of decaying signal. Okay, so here 0 1 2 3 4 5, and this will be n, and this will be xn. Okay, so this here you have a signal, and you are asked to find the discrete Fourier transform. Okay, so you are asked to find the discrete Fourier transform. Okay, not the Fourier transform. If you are asked to find the Fourier transform, okay, so what is that? If you are asked to find the Fourier transform, okay, the answer should be this. These words are very important. Okay, so here discrete Fourier transform, that means DFT. That is DFT. Okay, so you are asked to find the DFT. So if you are asked to Fourier transform of this continuous, discrete time signal, so it will be like this. It will be x omega, okay, sigma n from 0 to minus infinity. Okay, sorry, plus infinity, because this is goes up to plus infinity. Okay, this is goes up to plus infinity. Okay, so you have xn, that means minus 4n, 1 by 4n, e to the power minus j omega n. Okay, so this will be the Fourier transform. Okay, so you can write some value here. Okay, so if the n is equal to 0, it will be 1. Okay, so n is equal to 1, it will be 1 by 4 e to the power minus j omega. If n is equal to 2, it will be 1 by, so it is 2, so 1 by 16 e to the power minus j 2 omega. So on, you can write some terms up to infinity. Okay, so this will be the discrete time Fourier transform, not DFT. So how to find the DFT? Can anyone tell me how to find the DFT? To find the DFT, you have to consider endpoint. You have to consider uh, what is called, you have to consider some finite points. Okay, so you have to consider some endpoints. Okay, so actually this should be n point DFT. Okay, I'm not sure actually this one. Okay, sometime here it is not mentioned endpoint DFT. Okay, sometime maybe he expect the DTFT maybe. Okay, but I think it is not fair. Okay, because we need the if it is discrete Fourier transform, it is always DFT. Okay, if you put here time, discrete time Fourier transform, maybe it is okay. Okay, you have to find the Fourier transform. Okay, but here it is DFT. Okay, so it should be endpoint. Okay, so I think you can write like this. I think so. You can write like this. Xk. Okay, so this is the definition. Okay, xk. So I am using this definition. Okay, actually. So here n from 0 to you can put L here, but I will put N because I can get 10 points, no? Because the here in this function, the points will go up to minus infinity. So I can get any point. Okay. So I can get N up to N. Okay. So if you have only four points, but this N point can be 10 or 11. Okay. Then this will be 0. Okay. I think you have idea this. Okay. Because you have already done. Okay, so I will get 10 points. Okay, so I have like this power, okay, e to the power minus j to 5k to 5n k. Okay, so if you write these terms, I think you can get the full marks. Okay, but I don't know, sometimes this can be further simplified using the power series. Okay, using power series, this can be simplified. Okay, okay, actually this one also you can be simplified using the power series. You already know that. So this is the infinite power series. You can use the Taylor series. Okay, so but this is not infinite, this is finite. Okay, this is finite, but also you can use the Taylor series. Okay, I hope you can use our let's try. Okay, I think it will be important for you. Okay, so I will do it because I think we can use that uh, basic Taylor series that we are used in Z transformation. This one, 3, 4 up to infinity. It should be 1 minus. Okay, so can you remember this one? Okay, So we have this kind of power expansion. Okay, so this is a Taylor series actually. Geometric power expansion. Okay. Okay. So so you can see that only endpoints are there. Okay. So let me write like this. Okay. I can write this as 1a plus a square like that up to an. Then I have an plus 1, an plus 2, like this up to infinity. Okay, so it will be again 1 by a. Okay, I don't know this n value. That n value may be 10, 12, 13, 14, 100, 10,000, any value. This n can be any value. Okay, so anyway, I can write the power series in this way. Okay, so here I need only up to here. No, I need the value only up to here. These I no need. These values I no need. Okay, so I have to reduce this value. How to reduce this? Okay, how to reduce this? Can anyone have idea how to do that? Okay, we can simply use this one like this. Okay, actually I have done this before. Okay, I have done this before for other questions. Okay, so I have this idea. Maybe you doesn't have this idea. Okay, now you can learn it. Okay, you can use this power series for many application, actually for many mathematical simplification. Okay, so this will be like this. Okay, up to infinity. Okay, so I want to, so okay, I want to get this value. Okay, so if I write this, if I write like this, okay, if I write like this, a n plus 1, okay, then I have, so I have here a1 plus a2 plus a3 up to infinity. No, no, we can't do it like that. Okay, I think so. Anyone have idea how to get rid of these terms? It should be possible. Okay, I think okay, I can write like this. Okay, so I have these terms: a n plus 1 plus a n plus 2 up to infinite. No, there are infinite numbers. Okay, so I have to find some value here. Okay, I have to find the expansion here. Okay, okay, so I can okay, I can write like this. Okay, so I can write the same thing like this. A, so I get minus n out. Okay, I get minus n out. Okay, correct. Okay, so if I get minus n out, so here a n plus 1, what is this will be? So it will be a1. Sorry, I will get here minus, sorry, if this is endpoint, so 0 to endpoint, no, so this should be n minus 1. Okay, this should be n minus 1. Okay, 0 to n minus 1. So we will have endpoint, no, 0 to n minus 1. Okay, so that we will have endpoints, correct? Okay, so here also I should have, okay, okay, I will do it. Okay, I will do it. Okay, I'm sorry. So here now we have the yn. Okay, we have xn. Okay, I'm sorry. We have xn, that is half n un. Okay, so this is our sequence, time sequence, okay, time domain sequence, okay. So we have to find the DFT, okay. So what is the definition of DFT? Okay, so we have to find the endpoint DFT, okay. We have to find endpoint DFT. So definition of DFT is xk, okay, xk is equal to, okay, sigma 0 to n minus 1, okay. So this n is 0 to n minus 1 xn e to the power minus j. Instead of omega, I can put 25k divided by n. Okay, so this is the definition of DFT. Okay, so this is the definition of endpoint DFT. Okay, so in my case, I can write this as xk is equal to, okay, so here also I'm going to find the endpoint DFT. Okay, so I have n equal to 0, n minus 1. Okay, so xn will be half n. Okay, I no need to use un because I get 0 from 0. So un will cancel. Okay, 0 to n point 1. Okay, so my function, okay, so my xn will look like this. Okay, so my xn will look like this. Okay, so my xn okay, so this xn and here n, okay, so xn will look like this. Okay, so you have this kind of decaying signal up to infinity. Okay, so we are getting some n minus n values, okay, from 0 to n values, okay, from 0 to n values. So this point will be n minus 1 because including 0 we have n points here. Okay, so I am getting that 10 point. Okay, so I no need to consider this un because un is already there. Okay, okay, so I will write this like this, half n, then I have to find this term j, okay, 25k capital N divided n. Okay, is this okay? Is this okay for you? Any problem? Any issue? Okay, okay, okay. Now, so if you have any problem, you can ask me. Okay. So now I want to simplify this more. Okay. So using the power series, I hope we can simplify this to up to some level. Okay. So first one is, if I write our this power series, I think we are familiar now. Okay. Therefore, up to some a n minus value. We don't know this n value. It can be any value. Okay, 10, 12, 14, 13, any value. Okay, so you have an plus a n minus n plus 1 like this up to infinity. So you will have 1 minus a. Okay, correct. So this I think you clear. Okay, because this is a Taylor series. Okay, basic Taylor series expansion. Okay, so now I need the terms up to this. Okay, I no need the term from here I know it. Okay, now I'm going to reduce this infinite number of terms. Okay, for that I will do like this. Okay, so I will get, so I have an plus 1 like this. Okay, so I have an plus an plus 1 plus an plus 2, likewise up to infinity. No, okay, now I get out a n minus 1. Oh, I just multiplied this by a n minus 1. So what happened here? If I do like this, what happened? Okay, so you can see that. Okay, so we have a n plus an plus 1 up to infinity. Okay. Okay. So I just multiply this by a minus n. So what happened? Okay, what are the terms I will get? So a minus n, a n, I will get 1 because a to the power 0, I will get 1. So a minus n, n plus 1, so minus n cancel out, I will get a. Okay, so here I have a n plus 2. Okay, so minus n cancel out, so here I have a 2. Here I have a 3, a n plus 3. So n plus 3 minus n, I have a 3. So on up to infinity again. Okay. So this also will be equal to 1 by a. Correct? Okay. So I hope you get it. Okay. So this one also I can equal to 1 by a. Correct? Okay. So this one also I can get the same series from here also. Okay. Now if I if I multiply these terms by a n minus, okay, so I'm dividing it a n minus 1. Okay, and this side I divide in a n a minus n. So this one cancel out, and here also I will get a minus n. So minus n is there. If I get it out, it will be a n. Correct? Okay. So I will get this like. So what now I should I do? I am just so I have the value from here. Okay, I have the value from here, and that will be this value. Okay, now I am going to reduce this terms from this. Okay, I'm subtracting. Okay, what happened? So this part and this part will be same, and it will be cancelled out. So you will get up to here. Okay, so this is the formal way actually. This is a formal way to get the finite sequence. Okay, so if you I think in A level we have done this, no? Okay, this is the finite way. This is a standard way to get a finite sequence. Okay, so here I have a n minus. So here I have 1 minus a multiply subtracted by n 1 minus a. So my answer will be 1 minus a n divided by 1 minus a. Okay, so this will be the answer. Correct? I think I haven't done any mathematical mistake, numerator mistake here. Okay, I think this will be okay. Okay, I think this will be okay. I can remember. Okay, I can remember actually this is the answer. Okay, yes, I think it is okay. Okay, now I am going to apply this result to here. Okay, now I am going to apply this result to here. Okay, so if you look at this result, you can see that it is finite power series. No, it is n from 0 to n minus 1. Okay, so you have here, you can write this like this: quarter e to the power minus j 25 k divided by n. Okay, and this whole term goes to n. Okay, so this will be like a n. Okay, so if you expand this, you will get a0 plus a1 plus a2, and this will be the a. This will be equal to a. Okay, so I can write this term. Okay, this term using this result. Okay, so my xk will be xk will be 1 minus quarter e to the power minus j 25k capital N divided by 1 minus capital K, and here it should be n. Okay, so here n. it should be multiplied by n, and this one will be 1 minus quarter e to the power minus j to 5 by k divided by n. Okay, so this n and cancel out, so you will get this result, 4 e to the power minus j to 5k, 1 minus 1 4 e to the power minus j to 5k divided by n. Okay, so this will be your answer. Okay, so this will be xk. Okay, so this is the compact form for the that kind of DFT DFT signal. Okay, DFT transformation. Okay, so this is the answer. Okay, okay, please when you are doing this, please check whether I am doing any plus or minus change. Okay, maybe so sometime when I am doing the calculation, I have done that mistake very often. Okay, so please check it whether I am doing any minus or plus mistaken. Okay, otherwise this will be the procedure. Okay, and I think this result I am sure. Okay, because I can remember this result I can remember actually. Okay, I have remember. Okay, so this can be okay. Okay, so now that part is over. Now we are asked to show that the Fourier transform of xn an sin omega. I think okay. So we will first try to draw this signal. Okay, so if you couldn't understand what to do, okay, so please try to draw the signal. Okay, try to draw the signal. So if you are doing any engineering work, actually design work, you can use MATLAB or something. Okay, but in exam you can try to draw the signal. Okay, then you can sometime you can get idea. Okay, so here we have x bar. Okay, what is that signal? So I will get this here also. Okay, okay, so this, okay, so x bar n we have given like this: an sine omega naught t un. Okay, okay. So I think it's better if you given this n. Okay, if you given this as n, I think it is better. Okay, but I think no issue with this t also. Okay, we can get some result with this t. Okay, because actually this is somewhat equal to sampling. Okay, so if you draw a sine signal like this, okay, and if you multiply it with the unit step function like this, okay, like this, so this will be 0 1 2 3 4 5 6 7 8, and this will be t. Okay, so if you multiply this, okay, and this will be n. Okay, so you know that this n is also related with the time. Okay, related with the time. Okay, so these are actually times values, but the 1 2 3 are not, this is not 1 second 2 second 3 second. Okay, so I think you can remember the so in sampling we have learned this. Okay, so this corresponding t, okay, will be equal to nt. Okay, so this t is the sampling period. Okay, sampling period, because this kind of discrete signal we get from sampling. Okay, so this is this 1 2 3 4 always. So this n is the 1 2 3 4 value, this t is the sampling value. Okay, for say that t is 1 millisecond, 1 microsecond, so this time will be 1 microsecond. from here to here, it will be 2 microseconds likewise. Okay. So this 1 and 2 always related with time. Okay. Okay. So you can see that if you multiply this sine signal, sine omega t with this one, okay, you will you will have the value exact. So you are multiplying. Okay. So here you can say that here this value you have 1 and this value you have 0. So you will get 0 here. Okay. Now what about this value? There are no any value here, 0. Okay. For this value you will get 0 because these some values are there and it is multiplied by 0. You will get 1. You will get 0. Okay. What about at 1? Okay. So this 1 is corresponding to some time. Let's say it is 1 microsecond. So what happened at this 1 microsecond? So you have one value and here you have some value. So you will say that this is 2.5. So 2.51, you will get 2.5 here. Okay. And here from here to here, no 0 value. So from here to here, there is no value. So what about that 2? So let's say that it is 2 microsecond. So you will get some value here like this. Okay. So you will get this kind of samples. Okay. This kind of samples only if you have multiplied this continuous time with the impulse train, with this impulse train. Okay. Actually, this is sampling. Okay. This is sampling. This is called ideal sampling. If you can remember, this is called ideal sampling. Okay. So you can multiply your xt continuous signal with the impulse train. Okay. Then you will get this kind of sample. Okay. In formal way we write like this, no, if you can remember, xt delta t minus nt or something. I can't remember actually. Okay. I will let you know. Okay. Like this. Okay. So actually it is ideal sampling. Okay. So you will have some sample here. Okay. So this t can be n, or if it is n, no issue. And if it is t, it also not issue. Okay. So you will get, once you multiply it by un, you will get the sample signal. Okay. Correct. Okay. So I think now you have idea. Okay. Now I think we can go. Okay. We can move. Okay. Now we are asked to find, see, we are asked to find x omega. Okay, we are asked to find x omega, not x bar k. If you ask to find the x bar k, what is that? It is DFT. But here you are asked to find omega. So that means here it is DFT. So here you are asked to find the Fourier transform of discrete time signal. Okay, or DTFT. Okay, you are asked to find the DTFT, not DFT. Okay, not DFT. Okay, so I think you can you can do it. I think it is not much difficult. Okay, so here you can see that so if I write this signal, so you in here, so you have only this sided plus sided value. Okay, you have plus sided value. Okay, so here you have to consider up to infinity. Okay, you have to consider up to 0 to infinity, because that is the definition for the Fourier transform. Okay, so if I write the Fourier transform definition, it will be n from minus infinity to plus infinity, but this n start from 0. Okay, because here we have un. Okay, so we have only this sided value. Okay, causal signal. Okay, so we have 0 to plus infinity. Okay, and we have this one an. Okay, sine omega naught t. Okay, we have sine omega naught t, and we have e to the power. I think you can put n here, no issue. Okay, because if you if you multiply it by this n, okay, so you get the time point. You get this time point related with this n, no? Okay, so you can put n here directly. Okay, so So I will put n here directly. Okay. Actually, it is not completely wrong, completely correct. Okay. Because we have to nominalize this frequency. Okay, we have to nominalize this frequency when it is writing in sampling process. Okay, in sampling, if we are doing the sampling for this one, we have to nominalize this. Okay, we have to nominalize with this t. Okay, with this t. Okay, with the uh, sampling time, sampling frequency. We have to nominalize it with the sampling frequency. Sampling frequency also related with t. Okay, but here I assume that this 1, 2, 3 as the t itself. Okay, so here I just assume this time and this n as 1. Okay, so I instead of this t I put n. Okay, it is not completely correct. Okay, but I think here some we are not given more details about that, about this sampling. Okay, so if we are given the details about this sampling, at least if we are given the sampling frequency of or sampling time, we can do likewise. Okay, otherwise we have to assume that this 1, 2, 3, 4 are equal to sampling period also. Okay, okay, so this t, I just get this t directly equal to n. That means I assume that sampling period is equal to 1. Okay, that is my assumption. Okay, there is no way to do, no. Do you have any suggestion? Okay, anyway, we will apply and we will try to get this answer. Okay, I think if we can get this answer, we have to prove this, no. Okay, if we get this answer, I think it will be not be issue. Okay, it will not be issue. Okay, okay, we will see. Okay, we will see. Maybe my approach may be not correct. Okay, but sometime we will see, because here it is said that we are given a hint. No, I have seen it now. Actually, we are given a hint, and it is sine omega. So it is in continuous time domain. No, it is in continuous time domain. Okay, actually, continuous time domain we get like this. Okay, in continuous time domain we get this. Okay, if you get the Fourier transform for sine omega t, okay, in the continuous time you get this. Okay, you have to apply the frequency shifting property to get this. Okay, but anyway you can get like this. Okay, if you can remember the Fourier transform for continuous time signal, you have to use the frequency shifting property and you can get this value. Okay, so I can't see, because if I want to apply this here, the sampling time or sampling frequency should be given. Okay, otherwise we can't map this n with the t. Okay, so anyway we will try this way. Okay, I think this question has a problem. Okay, maybe I am wrong. Okay, anyway we will try. Okay, so I'm going to do like this. So I put 10 here. Okay, I put 10 here simply. Okay, because I'm assuming that this one and this time and are equal. Okay, so I just put 10 here. Okay, so that is not tally with the sampling. Okay, because if we are using the sampling theory, we have to nominalize this frequency. Okay, I think you have learned the sampling. Okay, we have to nominalize this frequency. Okay, anyway we will try. Okay, and here we have e to the power minus j omega n. Okay, so this is our definition. This is our Okay, we will try. Okay, so I think it is better to write this in terms of e terms using the Euler formula. Okay, using the Euler formula. Okay, so I am applying the Euler formula here. Okay, equal to sigma plus infinity a n sine. Sorry, I'm going to apply the Euler formula. So you know Euler formula. Okay, j theta is equal to cos theta plus j sine theta e minus j theta cos theta minus j. So I can write this like way using this Euler formulas. Okay, I think it is clear for you. Okay, so we have n equal to 0 to plus infinity. Okay, and we have a n here. Okay, and I have um, um, here if I write this here omega naught n, so I can write this like this. Okay, e to the power j omega naught n, okay, minus to the power minus j omega naught n. Okay, and should be divided by 1 by 2j. Okay, I think we can get this answer because 1 by 2j is here. No? Okay, I think you are okay with this. No, okay, I'm using this Euler formula. Okay, I'm using this Euler formula. E j theta is equal to cos theta plus j sine theta, and E minus j theta is equal to cos theta minus j sine theta. Okay, so if I subtract, so if this is 1, if this is 2, if I subtract 2 from 1, okay, 1 by 1 from 2, 1 subtracted from 2, I will have this cos theta cancel out. So j sine theta minus j sine theta, I will have 2j sine theta. Okay, 2j sine theta. And I have this e j theta minus e minus j theta. Okay, so to find the sine theta, I have divided both side by 2j. Okay, so this side by 2j. Okay, so I use this result to here. Okay, it is clear. Okay, so here I have x omega. Okay, now I think I have a confidence now. Okay, maybe we can get the proper answer. Okay, so 2j I get out. Okay, so 1 by 2j I get out. Okay, so we have n is equal to 0 plus infinity. Okay, so here, sorry, here also one part we missing. We have that part v minus j omega n. Okay, so we have this part minus j omega n. Okay, so you can see that I get half j. Okay, so this a n is there. Okay, so I write. Okay, so I think I can get the answer. Okay, so I write. So you can see now we get this part out. Okay, so here I write here 1 by 2j. Okay, so I have a n e to the power j omega naught 10 minus e to the power j omega naught 10. So I have to multiply these two terms by a n e to the power j omega naught 10. No? Okay, so I multiplied. Okay, so I first this I multiplied this one. So I have a n e to the power j. So you can see that j omega naught 10 multiplied by e minus j omega naught 10. Okay, so I get j, we have j common, I get j common. So I have omega naught minus omega, and this n also common. So you have this one, correct? Okay, I think in our results also we have the same thing. No, I think we are gradually, yeah, I think it is okay. No, omega naught omega minus omega naught is there. So here again I will so I am dividing this two. Okay, so again I have minus. Okay, so this I can have to, so for these terms all these are common. Okay, so there should be 1 by 2j. Okay, sigma n is equal to 0 plus infinity. Okay, So now I have an, again I have an, okay. Now I have this one, e minus j omega naught t minus j omega naught 10. So if I get e minus j, it should be omega plus omega naught. Okay, it should be omega plus omega naught, because this is minus omega naught, here minus omega. So I get minus out, it should be omega plus omega naught. Okay, so then I have n. Correct? Okay. Okay, I think now we can get the answer, no? Okay. 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 So now you can see that. So we have this term. Actually, this is a power series, no? This is power series. Same. You can use that one. 1 plus a square 1 plus a minus a. Okay, so you can use this one. Okay. So if I use this power series expansion to this one, I will get 1 by 2j. Okay. So instead of this a, I have a e to the power j omega naught 10. Okay, because I can write this way. I think these are clear for you. Anyway, I will write. Sometimes some students are not good at mathematics sometimes, no? Okay, so this is 2j. Maybe you have forgot, okay, because you have done maths in A level and you have get some good result, no? So, so I think these are clear for you, okay? Maybe you forgot now because you are doing jobs, no? Okay. So you can see that so this n and this n common, so you can write this like this, okay? E j omega naught divided by omega, the total n. Okay, so this will be our a. Okay, so this will be our a. And we will have, okay, so x omega will be 1 by 2j. Okay, so 1 divided by, so this will be my a. Okay, so it will be 1 minus a e to the power j omega naught omega. Okay, okay, okay. So here I have minus sign and 1 by 2j here, so I get out of 1 by 2j, and here I have minus side, and this part you can see that this also we can use the same expansion, same power series expansion. So you will have, minus 1 minus a, okay, a, and e, so here minus j omega naught plus omega. Okay, so this will be my result. Okay, so is it okay? So you can see 1 minus j omega naught here minus. So I think we have changed. So here it is minus, and here also it is minus, no? But here we doesn't have a minus sign, no? So any mistake we have done? So this part is okay, no? This part is okay, and we are having a problem with this minus sign. Okay. So here it should be minus sign according to the answer. You see. So have you missed anything? So sine omega naught we can write as e j omega naught Hmm, I don't know whether I'm making a mistake, but actually I'm not sure about my approach also, okay? Uh, because sometimes we can use this, but I think we should be able to, we should be given, we take omega naught minus omega, yes. Yes, yes, okay, okay. Thank you, okay. Yeah, so we are correct, no? Okay. So here actually this is omega minus omega naught. So I can take minus out here. Okay. So I think our approach also should be okay. Okay. Because here you can see that. So we have like this j omega naught minus omega. Okay. So if I get out minus value here, minus, okay, so this will be omega minus omega naught, no? This will be omega minus omega naught. Okay, thank you. Okay. So we have omega minus omega naught. Okay. So our answer is correct, no? We get the answer. Okay. And I think this approach also, I think if you are going to use this result, okay, if you are going to this result, also you can assume as t is equal to n, okay, otherwise you can't get the value, okay, because t is equal to nt, okay, so you have to assume that t is equal to 1, okay, the sampling period should be equal to 1 second, okay, then this n and t will be equal, okay, then n and t will be equal, okay. Otherwise sometimes we can use this approach to get this answer, okay. uh, but I think you have to use some properties, okay, otherwise you can't get the value, you can't get answer, okay. I hope this kind of question will not come to exam, okay, anyway, okay, but this can be done, okay, this is basic approach, so this one is a basic one, okay, so you have to understand, and I think this one also very basic one, okay. So here you are asked to draw the magnitude spectrum, okay, you are asked to draw the magnitude spectrum. I think it is if you are going to draw it by hand, it is very complex, okay, because you can see that, so here x omega, okay, so here x omega, uh, okay, and here you have a complex value, so if you can see, this is a complex value, okay. So first you have to convert this into a complex form, okay, a plus sorry, x plus iy form, okay. So you have to convert this x plus iy form, okay. So this x you have some omega value, and this y also you will have some omega value, okay. So to find the magnitude, okay, you have to get x square by y square, okay, square root. So this will be the x omega, okay. So you have to put some value for this omega, okay. You can say omega is equal to 1, 0, 1, 2, 3, like that, -1, -2, -3, like that. Then you have to calculate. So you will get this x and y with omega value, okay, with the omega, okay. This omega and omega naught is there, okay. This omega and omega naught also there, okay. So you have to evaluate this value for different omega value, okay. Then you have to plot this, and you have to mark this, and you can plot, okay. You have to plot, okay. But it is very hard, okay. If you are doing manually, it is very hard. I am not going to do it because it will takes many times, okay. I think this kind of complex number can be converted to this, okay. In A-level mathematics we are done these things, no, okay. This kind of complex, any complex number we can convert to its standard form, x plus iy form. Okay, then you can find the magnitude, and also you can find the phase here. Okay, phase will be tan inverse y by x. Okay, so you can draw the phase spectrum also. Okay, but it is very hard, and we are not given this omega naught value also. Okay, so we can't get proper values for that one. Okay, okay, so we are, so this omega naught, we don't know what is the omega naught value. Okay, so we are, it is very hard to draw the spectrum. Okay, but sometime you may calculate one or two values, and you can just say the spectrum is like that. Okay, that is enough. Okay, and you can't use the MATLAB, because if you are given this omega naught value, you can use the MATLAB. Okay, easily you can use the MATLAB. Okay, so what you have to use that, do is that you have to type this one in MATLAB. As it is, you can type in it MATLAB. Okay, and you can assign some value to omega, then you can plot omega versus this value, then you can plot the magnitude. Okay, but omega naught should be there. Okay, okay, so I think you can do it. Okay, okay, so we will see the next one. Okay, I think the next one, okay, so if xn become a finite duration sequence. Okay, so so it is said that xn become a finite duration sequence. I think in that case you can draw the magnitude plot and a phase plot. Okay, so we will see. Okay, so you are given xn. Okay, that is okay. Okay, so now we are going to do this one. Okay, so xn, okay, is equal to half n, sorry, I'm sorry, we are going to do this one. Okay, we have done this one, and we have done this one, we have done this one. Okay, now we want to do this one. Okay, so here we are given x hat 10, another sequence, so it will be 1 from 0 to n. Okay, so it will be 1 1 1 1. Okay, so this will be 0, and this will be 1, this will be 2, this will be 3. Okay, so this is our sequence. It is a finite sequence. Okay, so very easily you can find the x omega. So we are asked to find the Fourier transform, not the discrete Fourier transform. I think here also, I think we are asked to find the Fourier transform. Okay, not the discrete time. Okay, because this is Fourier transform. We are asked to find the discrete version of, sorry, discrete time Fourier transform, not discrete Fourier transform, not DFT. Okay. So I think, so if you ask to find the so I have explained now how to find the DTFT here also. So you have the answer. Okay, so this x omega will be, okay, so you know that n equals 0 to 3. Okay, xn e to the power j omega n. So if I expand this, very simple, x0 will be 1. Okay, it will be 1, and the n should be n here 0, so e to the power 0, it will be 1 plus. Okay, so x1 it will be 1, then we have e to the power minus j omega plus n is equal to 2, xn is 2, e to the power j 2 j omega, okay, plus 1 e to the power 3 j e to the power 3 j omega. So this will be my x omega. Okay. So this omega will look like this. Okay. I don't know what is meant by look like. Okay. So I think it will look like this now. Okay. Okay. So it will look like this. Okay. I don't know if they are asking to compare it with some other one. Okay. But anyway, so we will have like this. Okay. So we will have like this. Okay. Now, actually, for this one, you can draw the phase spectrum and uh, frequency spectrum, magnitude spectrum. Okay. For that, also you have to convert this. Okay. You have to convert this to x plus jy terms. Okay. Jy. Okay. Otherwise, you can't do this. Okay. Then you can find the magnitude here. So magnitude will be x square y square root. Then you can change omega value and you can plot the x. Okay. So here with these terms, it is hard to find the, for me, it is hard to find the magnitude. Okay. Magnitude and phase. Okay. Maybe some, if you actually, this is the polar form. No? Okay. I am not dealing with the polar form very much. Okay. So once, so normally I am doing in Cartesian form. Okay. So maybe there are some in polar form also, maybe there are some simple way. Anyway, you can use MATLAB. Okay. Like this. Okay. For example, I think you can see my one. Okay. So you can write this. Okay. So you can assign some value to omega. Okay. So you can, so this omega is actually continuous variable. Okay. If it is not a discrete time, this DFT, this omega is a continuous time. So you can define it in continuous variable form. Okay. So that means I am getting very small step. Okay. Very small increment. So it will look like a continuous wave. Okay. Continuous variable. So let's say up to 20, I'm going to plot. Okay. Not this may be not 0. Okay. Omega may be minus side also can be there. Okay. Okay. So now I'm just write at my x omega. Okay. So what is my x omega? X omega is equal to 1 plus, okay, exp exponential is the value. I'm not typing all the values. So minus j omega. So minus j omega. So I have minus j. I can type like this 1i. Okay. So it is j. Okay. J omega. Okay. So I have plus. Okay. So I will take this one. This. Okay. So here we have 2. Correct. We have 2. Okay. Here we have 3. No. Here we have 3 like this. Okay. So like this, you can type the expression itself as itself. Okay. And you have to get the absolute value here. Okay. So MATLAB will calculate this. However, I don't know. He will, maybe he can convert this to the Cartesian form or something. Okay. So this is the absolute value, magnitude. Okay. So I can simply plot it. Plot omega x omega. Okay. So if I run this, I should have the magnitude plot actually. Yeah, my magnitude plot will be look like this. Okay. So if I want to plot the phase plot, okay, I have to, instead of this magnitude, I have to get the phase. Okay. So for phase, I can't remember the command. It should be angle or something. Okay. So you can type it. If you can't remember, you can type it here. Phase in MATLAB, maybe it may be given. So, I don't see. Phase plotted, phase plot. Yes, phase plot. Phase in MATLAB. Yes, this one angle. Okay, so you have to use this angle. Okay, so if you plot the angle, okay, so you can get it. So your angle will be look like this. Okay, so your face will be look like this. Okay, correct. Okay, so likewise you can uh, plot the, but if you are going to plot in manual, first you have to so in my, if I am doing this, first I change this terms using the Euler formula, okay, to the Cartesian code like this, okay, using the Euler formula. Okay, then I I I add all the imaginary parts, real parts, then I can get the real parts, and I add all the imaginary parts, then I get the imaginary parts. Why? Okay, then I have the imaginary part and the real parts, then I get the square. So it will be, so I am changing, so this x and y will have the omega value. Okay, so this omega is the angle, so it will here, okay, it will in this term, so it will in x and y omega, y terms. So I can change the y value and I can calculate some magnitude value and I can plot it. Okay, so it will be my phase plot. Okay, and in the same way I can so it will be my magnitude plot. In the same way I can find the phase using tan inverse y by x. Okay, so here y terms and here also y terms. So sorry, here also omega terms and here also omega terms. So I am changing the omega some value 1 2 3 4 like this. Then I calculate tan inverse y by x. Then if I plot, it will be my phase plot. Okay, so I think this is okay. Okay. Okay, I will do that one also. Otherwise, so if you are tired, you can leave. Okay, and I will do the next question also, and I will stop because I don't have much time. Okay.